A quick intro about me. I've been in the industry for close to 2.5 decades, and I've worked in companies. Currently, I work for Atlassian, and prior to that, I used to work for companies like PayPal, Intuit, Oracle, etc. Right? And the thing that I am very passionate about is building platforms that can actually solve more than one use cases. End of the day, you build once, automate it, and ensure that you solve for multiple use cases. So data management is something that I'm driving in Atlassian. I lead a group which is known as Cloud Transition Platform, which is responsible for moving customers from on-prem to cloud, as well as handle a lot of data management capabilities, right? And we have a product. I'm not going to do a SaaS session or marketing session on Atlassian. I'm going to tell you this is the last pointer that I'm going to talk about Atlassian. Atlassian, like many of the startups and other companies, is also foraying into AI world. And we call AI as Atlassian Intelligence. And you can imagine, that's the first slide I want to start talking about, because in today's world, every startup, every enterprise, every company needs to have AI. Right? If you want to attract talent, you need to have AI. If you want to have a powerful resume, you need to have AI. Right? And LinkedIn, you will find 101 posts on a single day talking about LLM techniques, tricks, how to actually be the master of the next big thing in AI. And if you want to invest, NVIDIA, my brother works for NVIDIA, right? Right, I shouldn't be doing any work, but unfortunately he doesn't want to part with his stocks, right? So now that is the hype around AI, but the reality is this. The reality is, I'm sure many of you know this picture, right? Honey, I have a feeling we are not in Kansas anymore, right? So the reality is, even though it looks very, very glamorous with AI, end of the day, it is not about building your LLMs, because that's an easy problem. Your bread and butter problem is about data cleansing, data management. It's about providing all the trusted capabilities about data, which makes your customers, your enterprises happy. Right? So that's the topic that I'm going to talk about. What we are going to do is take a bunch of scenarios. If you are building a cloud platform, whether it's a SaaS platform or it's a infrastructure or a capability or a service that you want to provide for your customers, what kind of data management do you want to think about? What are the constraints that you will hit in a real world? What are some of the possible solutions? So we'll stay at that elevation today, especially given that it's a Friday afternoon. Okay, but feel free to interrupt me any point in time. So this is what I talked about, right? For all the glamour that we saw in the first slide, this is what you deal with when you actually work with AI. Even before you can build AI, you have to support GDPR, you have to support FedRAMP, you have to support PCI, you have to support God knows what all compliance, security, encryption capabilities that you'll have to deal with. And that is the reality. That is the reality if you enter in the cloud, because nobody trusts the cloud. Even Amazon doesn't trust the cloud. I hope there is nobody from Amazon here. But neither Amazon, neither Google, neither Azure or Microsoft support their own platform, because it's a wild west out there. And you got to take care of fundamental compliance, security, and data governance and data management capability. So that's the realm of our conversation today. So when I talk about data, what are the kinds of data? First and foremost, we provide a fundamental or underlying infrastructure for making our software, a SaaS or a platform or your API or a capability work. You can think about a user-generated content, right? So if you are, I can take the example of Jira. If Jira is there in the cloud, your issues become your issue data. Your Confluence pages, the content that you add in Confluence becomes the content that you add. So if you are in a booking, airline booking system, it's your travel data that's actually coming in, right? Now, in a multi-tenanted architecture, each tenant will have their own customizability. You may build a very basic version, but over a period of time, you're going to enhance your capability to support different customizations per tenant, and that's a given thing. So the moment you start customization per tenant, you've got config. And handling configuration is a nightmare, right? So that brings in variability, but we are not going to talk about variability here, right? So that's config data. Now, irrespective of whatever kind of system that you deal with, you have to deal with large blob data. That is attachments. You've got to deal with images, videos, right? Data is very cheap. So we very recently acquired a company called Loom. And within our company, there is actually a tendency towards creating more and more Loom videos for collaboration. So there is a massive surge in the kind of attachment data that we have seen in use within our environment. And that's true, right? If you look at Insta, the number of reels that you deal with, the number of pictures that you deal with is much more than what you would have imagined 10 years back. So attachment needs its own classification. Then the fourth one is very important. That is identity data. Identity comes with its own problems. PII, personally identifiable information, different types of classification, type 1, type 2, multiple types of compliance. When you are in the payments industry, you have to be extremely careful. So if we go back to the previous slide, it's not refreshing. If you look at HIPAA deals with all your health data. In many of the Western civilizations, your health data is considered to be very private. We don't deal with that in India, but it's meant to be extremely private. So it includes your gender data, your health data, your weight data, your height data. All of that is meant to be private. In addition to other data that you can talk about, which is about your date of birth, users, telephone number, address, all of that. So that is the other identity data that you talk about. Now, if you are a very successful platform, you're going to be like, the flower which attracts a lot of honeybees around you, which is your third-party developer and the developer ecosystem. So when your customer deals with data, they expect you to handle your third-party ecosystem by default. So you cannot go and say, I'm handling this from my platform, but you know what? You've got an app vendor which is building a solution on top of it, and it's their problem. That doesn't work, right? Including AWS, if you are a platform, and if there are customers who are actually using third-party apps which are built on top of it, you need to be providing native capabilities within your infrastructure to handle data management. So there are certain things that you need to think about it, right? One, you need to handle variability in your system design. You need to handle large scale of data, which comes with attachment and user-generated content. You need to handle PII, which means compliance. And the last one, you actually need to have extensibility in the solution that you deal with. So when I talk about GDPR compliance, every country of late, especially when it comes to health data or when it comes to your financial data, there are rules that govern across multiple countries, multiple continents about GDPR, right? In fact, multiple companies have spent 2 to 3 years of calendar years just to comply with GDPR, right? So GDPR starts with, tagging your data within a particular geography, right? Of course, most of our cloud platforms, if you take AWS, GCP, or Azure, do support data residency. It starts with data residency. AWS, anybody knows how many regions AWS supports? Not 100 yet. 30. It today supports 28 commercial regions around the world, including 2 in India. Any prices? Don't look at the picture. There are 2 in India. Mumbai and Hyderabad, right? Good. So including 2 in India, and there are 2 Gov clouds. And we'll talk about Gov cloud. That's yet another emerging area for us to handle. Now, if you are a successful startup or a company which actually starts predominantly, you will deal with India, Europe, or US customer base. You start with one region. When you expand to another region, GDPR must be part of your strategy. Otherwise, you're going to actually take a big hit. And what is the hit? You will have to think about redeploying every single service that deals with PII data, that deals with variability, and you also need to provide extensibility, which is about third-party app data, when you deal with data. That's the most important part. Now, It's very easy. If I've got 28 regions, okay, I've got the money, I've got the funding, I can actually go and deploy all my services. I've got 100 services, deploy all the 100 services in all the 28 regions or 30 regions. It's very easy, right? But life is not that easy, because when you deal with GDPR, you have these three constraints that you need to deal with. The first one is data storage compliance. That means among all the types of data that we talked about, definitely PII data, user generated content, because you don't know what your actual users are going to enter there. So user data, attachment data, identity data, for sure you need to support GDPR compliance. And if you are a platform which supports a fifth data type, which is application, you also need to support data storage compliance. That's the constraint. Easiest way to solve: deploy all services, spin up 28 databases, 28 regions, bring it up, but then your cloud cost will shoot up, right? Somebody from finance is going to call you and tell you, give me a break, this cannot work. So then reality hits you. Then what you do is swing the pendulum on the other side. You'll start looking at, okay, these two services are the services that I need for me to deploy in the cloud. Let me deploy only 2 out of 100. That also doesn't work, because the center pillar will hit you, which is latency. So you need to have a trade-off between all the three pillars when you start identifying what is the right solution for you. So what are the different ways of doing that? The easiest way is manually identify all the services, deploy them one by one in each region, and then manage them. Think about the developer cost. Think about the developer productivity and the number of pipelines that you'll have to think about. And bugs are so common in our industry. So anytime you have a bug fix, how will you deploy these bugs in 28 regions? And in certain cases, you have decided to create a hell of latency optimization, right? Because you wanted to save for cost. So that is the fundamental problem. I thought of first drawing an architecture showing how complex Atlassian can be, but then I thought, no, my marketing team will come and tell us, please don't show that picture, because we want to attract good talent. But every single company goes through that infrastructure hell when it comes to dependency wiring, handling regions and GDPR. That's a reality, right? This is your foundation even before you start thinking about AI, right? So what is a solution for that? One possible solution is cell-based architecture for service hydration. How many of you know what is cell-based architecture? Anybody in this room? Do you want to talk about what cell-based architecture? One line.
Treating our application such that it is neither centralized or neither decentralized.
You're almost there.
It's
okay,
middle of
I'll wordsmith what you just said, but you're almost there. So it is grouping your services together wherever there is a dependency into a cell. And then you'll have to think about deploying a cell as a single unit. That's a fundamental premises, right? So if this is the whole gamut of my services, which is 100 services, I can think about collating them into 7 or 8 cells. Each cell, if you have a dependency on identity, that becomes a central cell. That's the reason, unfortunately, I can't go back and highlight it with laser. But think of those purple boxes as the 2 boxes which has got central common capabilities, whereas all the other individual colors are colors or cells which require isolated deployment per cell. That's the whole idea behind cell-based architecture. Advantage of cell-based architecture: every cell can be worked with one pipeline. And the moment you start thinking about a bug fix, think about bug fix rollout per cell, right? So that's the advantage of cell-based architecture. And when you talk about cell-based architecture, it is not just GDPR or data residency that it solves. Welcome to the world of FedRAMP. Anybody knows what is FedRAMP? FedRAMP, C5, please. Yeah, so US government has a regulation, and that's what I talked about as GovCloud, right? So in addition to region deployment, if you are a vendor, by the way, my friend Vinay is actually a founder of AirMeet, right? And if you are selling to, any vendor which is actually selling to the US government, Department of Defense. If you are first a lister vendor in Department of Defense in US or any of the government departments, you have to be FedRAMP compliant. What is FedRAMP? FedRAMP is meant to be a completely isolated environment which has no dependency on commercial environment. Think of it as an air bubble. So the idea is it's got 3 levels, right? FedRAMP moderate, high, and low. So typically you need to certify at least at a moderate and high level if you are a vendor to the government. Now there is high, FedRAMP high has one more regulation. If you are a FedRAMP high certified vendor, any vendor that you use internally in your software company should also be FedRAMP certified. So imagine the chain reaction, right? For example, if you've got draw.io or Glyphy. These are 2 diagrams that you can think of in Confluence. If these 2 guys or Miro are providers of FedRAMP software to the US government, if they use Jira, they have to actually have Jira in a FedRAMP zone. So that's a cascading dependency. So this becomes an opportunity for you to lose if you don't certify for FedRAMP. Now US government started FedRAMP. So Germany, European region, they are even more stringent when it comes to data governance because GDPR originated there. Germany came up with what is called a C5. So C5 is Cloud Computing Compliance Controls Catalog, right? And it's a matter of time before every single sovereign country comes with their own deployment requirements, which is geo-tagged and air bubble tagged. Now, one of the advantages of cell-based architecture is, with cell-based architecture, think of that cell getting deployed in an air bubble. So take US GovCloud from AWS, deploy your cell in US GovCloud, right? The only difference is, if you know of AWS S3 or Lambda functions, the way they work in GovCloud is very different. The latency is very different, right? Because different services work differently in different environments. That's the thing that you need to notice. Now comes single tenancy versus multi-tenancy. So Pepsi, Coke, everyone knows. So if your company actually supports 2 competing tenants, they are going to actually make you sign a deal as part of their compliance check. They cannot be part of a multi-tenant architecture where they coexist with their competition, right? You can think of Samsung and Apple will never be in the same tenant. You have to guarantee that even before you get them. Similarly, Pepsi and Coke cannot be, right? So these are some of the basic criteria that you think about. But as you move up the stack, when you deal with financial institutions like Morgan Stanley, JP Morgan, or many others, or Fidelity, they'll start telling you, give me fully isolated environment. So equivalent of GovCloud, but they are telling you that give me a single tenant architecture. So single tenant architecture, again, same set of problems. So with a cell-based architecture, how many use cases did you solve now? And you actually moved up the ladder in terms of what kind of enterprise level or grade maturity that you have actually moved up. So that's one of the solutions that we talked about. Now let's move to the next problem, which is backup. Backup is a very common name, right? Seems very simple. In your desktop, you just take a right click and save it to another folder or take it in a USB. Now apply the same concept in the cloud, and in your multi-tenant environment, all hell breaks loose, right? That's exactly what happens. So there are multiple facets of backup. You start with a simple backup because companies might want to ensure that, hey, if there is a mistake in your employee, right, or your employee does an insider job after a tense situation in the office, you still want a protection. And that's where backup started with. But over a period of time, it started moving towards the other side, which is disaster recovery. So disaster recovery, of course, if you deploy in AWS, you can tell us that, hey, I'll do multi-AZ deployment and I get by default, disaster recovery. But that's not what we mean. Disaster recovery starts with RTO and RPO. Anybody definition of RTO? Objective, and recovery point objective. So your definition of RTO and RPO will define how much of your constraint you will have when it starts with backup. recovery time objective, recovery point objective. So what time do you want to go back? Imagine I'm a book building company in a finance sector. If there is a crash, right, if there is a disaster, how quickly can I cut over and when will I cut over? The site crashed at 10 a.m., right, and I brought it back at 10:05. So 5 minutes is my latency. And did I go back to 10 a.m. or 9:55? That's a recovery point. Okay, so that's your disaster recovery. And in many cases, for example, if you are in the travel industry or in healthcare industry, you will have to take periodic backups of your employee base, of your customer base, and keep it for legal hold. For instance, you can have some litigation, and you need to keep data for hold for recovery purposes, compliance purposes in future. So it's not just the backup that you keep within your system. You need to enable your backup to be exported. Of course, export comes with import use case. So export import becomes use cases that you need to handle. Now, what are the constraints that you will deal with? Obviously, data consistency, which is what I started talking about with RTO, RPO, right? So that's the first point. And will you actually allow me to take a snapshot of your entire system of microservices? If you have got 100 microservices, when I take a backup, I would assume all the 100 are at the same point in time snapshot when I restore it. Imagine if you are doing an invoicing or a financial accounting software or related to that, and different services are at different levels of consistency. I mean, your customer is screwed, right? So that's definitely one of your concerns that you will deal with. The second one is backup time. How much time does it take for me to take backup? We have customers who have got terabytes of data. When you have terabytes of data, your loss of physics will come into picture, right? Beyond a certain point, your network speed, you can only do with that much network speed. So how do you optimize for that? And there are ways and means which we will talk about. Last but not the least, every damn problem in the cloud becomes so easy until you bring in dollar into picture, which is your how do you optimize for cost? Because AWS will charge you not just for S3, but also for your metering, but also your egress, but also your ingress. The moment you start all these points, the amount of data that you transfer for your customer, you actually will end up having a problem. And I remember every time I look at the cloud cost, I remember the LinkedIn forwards around. I used to be a billionaire until I left my AWS meter tap turned on, right? Many of you would have seen that. So backup can actually take you there. So at some point in time, a backup will eventually lead to a charged feature. Because if you want to have daily backup of 100 terabytes of data for your customer, you are going to charge your customer, right? Ultimately, you'll have to pass that charge back to the customer. So what are the options in front of you? We are talking about that. Yeah, thank you. I think that means my slide is getting engaging, right? At least one person is listening. So you've got 3 types of backup. What are the 3 types of backup? I'll start from the right, which is export and import of full data and backup, right? You will do it for compliance use cases where you will have to store the entire binaries, the 4 or 5 types of data that we talked about in your customer location, right? This is typically used by banks, domains like healthcare, telecom, which are heavily regulated, right? So if you have those kind of customers, you will have to start thinking about export, import. That becomes your fundamental use case. But if you are in an industry which you can actually support without having to support large cases of export and import of data, you can live with snapshots. The advantage of snapshot is snapshot lives in your infrastructure. So the advantage is you can actually keep your architecture in such a way that if you have storage of data, like attachments in many cases, is immutable. Every time you change an attachment, you are going to version it, right? V1, V2, V3, V4 of attachment, whether it's a picture or a motion file or an audio file, you're going to keep them. And those are the files. In Atlassian case, 85% of our backup data is media. And no prices for guessing. right? For all the war between a QA engineer and the engineer, this bug cannot be reproduced. The QA engineer attaches a picture, and the developer attaches a video back saying that no, it's not reproducible in my environment. All these come as comments in Jira, and who bears the brunt? Atlassian bears the brunt in the cloud, right? And the advantage of snapshot is you can have pointer-based backup. You don't have to have the full backup within your infrastructure. All you do is keep an S3 location, and there you take the backup of the data that is changing, and you just have a reference to the main data, which is attachment or your user profile, identity data, etc., which do not change over a period of time. And of course, the gentleman here talked about incremental backup. Incremental backup is a case where I take my snapshot on day 1, and for the next 14 or 30 days, I do CDC, change data capture, right? And then I build on top of that, and it is desirable in terms of restore and compute capabilities during restore to at least take a full backup once in 14 or 30 days, so that you don't have to, like 3 months of data, you don't have to start on month 1 and then go 90 days delta, right? You don't have to do that. So that's the advantage of incremental backup. Any questions before I go to the next slide? Yeah, that's what I talked about, export import. For compliance, you need to start supporting that, right? Whereas for companies who may not have a compliance requirement, they actually do it only for protection against an insider job or accidental mistake. You can live with snapshots. Okay, the next one is data processing. Data processing, internally we call this as use cases, like cloud to cloud use cases. So when you talk about cloud data movement, you could think of, if you're a very successful platform and multiple companies start using them, think of a day when your customers start having a relationship with each other. Imagine you start servicing a customer A and the customer B, and one fine day customer B got acquired by A. They'll have to unify their assets together. This is going to be a problem. Or when you start selling it to a big bank or a big financial institution or a Fortune 500 company, you will go through reorgs. Reorg is the nature of enterprises. So M&A, reorg, restructuring, or disinvestment or divestment. Or in general, they want to make sure that they have an asset attribution. In the age-old days, when software was built in-house, hosted in-house, right? Companies used to have an IT division and chargeback as policy. How many of you know what is chargeback? Chargeback is pretty simple. You maintain a simple Excel sheet from the CIO's office, maintain which VP needs to give what dollars to the IT department. That's it. Very simple, right? And somebody pays for all your hardware and the processors and the storage cost in your data center world. When it comes to the cloud, you will have to pay for licenses. And usually a single VP or an SVP in a large enterprise or a division has a license attached to them. Now, all of these use cases, imagine Dropbox. Dropbox might internally maintain 4 tenants for a large enterprise, right? That's how Atlassian works, right? Each department goes and buys their own instance of Jira or Confluence, and they are physically stored separately. Now, what happens during a restructuring of the company? You'll have to deal with large volumes of data movement. So the use cases that we are talking about are copy, move, merge, split. Actually, copy and move are very close to merge because you could do that together. But I intentionally called out merge because it could also be taking data from site A, site B, or a tenant A and tenant B and combine them into the third tenant. And this is all complex operation because I'm talking about 5 types of data, which we talked about in the very first slide. And we are talking about hundreds and hundreds of terabytes of data. So, and the constraints come here. Data consistency is a problem. We talked about it earlier. Downtime. Now, it's very easy if you don't bring downtime. I'm saying that, okay, bring down the site for the next 48 hours. Very easy for me to merge data, copy data, move data. But if both the tenants or both the departments have to have the sites up and running or the services up and running, they continue to ingest, process, modify, delete data, how are you going to achieve all the data management capabilities, copy, move, merge, join that we talked about earlier. Last but not the least, how do you deal with all of this without having a downtime, without incurring a huge bill in your cost? Because every time you enable API and API based data movement, you will incur AWS costs because of egress and ingress, because you are dealing with data movement by staying outside the network. How do you deal with all these data management capabilities within the network? So in Atlassian, what we have done is we have used Kafka streams. We have built a pipeline on top of Kafka streams and a control plane and a data plane, which we call as Lithium, which is a homegrown platform which my team has built that handles a lot of these governance, which provides the previous slide central piece, which is called remediation. So remediation is a very important aspect. When you deal with this large scale of data, that is 100 terabytes of data or 50 terabytes of data, if one or two files get corrupted, in an API driven world, you'll have to rerun the whole copy operation or move operation altogether, right? So in order to prevent that, an implementation of DLQ can be thought about, right? A dead letter queue implementation, and that will help you remediate. So you only operate on the subset of data which requires a cleanup. Think of a Windows Explorer world when you had 10,000 files to move and one file failed. It will stop and the whole operation, it will show you reverting back. Many of you would have seen that old image, right? When the data goes back. So that is remediation for us, and it can very easily be solved through Kafka Stream modern technology. So now the next use case that I want to talk about is Sandbox. In a on-prem environment, you would have heard of a pipeline. A developer develops, pushes it into a stage environment, and the stage environment goes into production. This is a natural dev loop that you can think of. But now when you are a SaaS vendor and you are building your software and your customers are developing on top of it, they are not using it, they're customizing it, they have custom scripts, application built on top of it, they would want an environment where they can test. What are the use cases that you can think about? So your stage needs to be provided by the SaaS vendor out of box, and that is what we call as the Sandbox use case. So it is done for a trust. Anytime they make a change, it can be simple configuration change, right? If you want to change your logo, your your parameters, all of that, what is mandatory when you actually use a particular form within your company for your tenant, you will want to test it in an environment. So that's the trust use case I'm talking about. Now, what is quality? Internally, the enterprises might actually build software on top of your platform. In that case, they still need a place for them to test. That's again the Sandbox. Third one is collaboration. Many a times they deal with partners, the Accentures, the IBMs, the Infosys, the Wipros, which build and customize software for them. And as part of the UAT process, you still need a place where you test them. And it is good advice to have a capability of a Sandbox out of the box as part of your SaaS platform. So again, go back to the optimization constraints. Now PII comes in. There have been so many cases when production data got copied into a dev environment, but one service, that one culprit service was common. We have had so many incidents where somebody copied data from production into test, made an edit that actually impacted the identity data of the real production server. It's very common. So it's important to have isolation and masking your data. Then you may want two-way sync, right? Customers want data copy from production to Sandbox or a stage environment in a masked format. They apply testing, they do all the configuration changes. They expect the pipeline to work backwards. So that is a two-way sync. Of course, cost is a concern because you are virtually giving one license free. The moment you give Sandbox, it's one license free. So you may want to have a tiered pricing model when you start thinking about Sandbox. Again, in Atlassian, what we have done is we have used the same Lithium pipeline, which is built on top of Kafka streams to move large volumes of data together. So I'll wrap up. I think I've just got 5 minutes, so I really want to leave questions, time for questions. The last part is data protection. Data protection ultimately narrows down to two key features. One is access narrowing, role-based access permission, and access narrowing at an API level, at an entity level, right? So that's access narrowing. The second one is protecting your data. One of the best ways of doing that is through bring your own key. That comes with key management capabilities, the overhead of key management. That's yet another topic, but I'm not diving deeper here. Those are the two areas that I wanted to cover as part of my session. I think my clicker has given up on me, right? Okay, we'll take questions for the next 5 minutes. Any questions on data management?
You're still deploying your entire app in separate regions, right? For GDPR.
That's
so
correct.
That is still happening. Is that you're reducing the number of services to a
single cell.
Okay. Yeah.
So that becomes like my mind cannot process 100 services.
Right.
I can only process groups of 10. So I'm logically grouping services which are always connected. Think about a user service and a group service. They always go together. So think of user and group together to be forming an identity cell, right? So what we are doing in effect, I didn't want to say this, for all the hype around microservices, you split your big bang monolith into microservices, you're combining them back into a cell. That's what you're doing. Yeah. Any more questions? You can take 2 more questions. We still have 3 minutes.
This is the effect of post-lunch.
Yes, yes. All right. Yeah.
Hi, sorry. I'm Sivam. I missed a part of your session, but right in the beginning you talked about different kinds of data. So data that we work with is IoT data coming from sensors. How do you categorize them?
That
is there
would be
anything?
user-generated data.
It'll be also
Because ultimately your IoT device captures somebody's tagging data, your attendance data or your biometric data that is coming in ultimately. So that is user-generated data. In the classification that we talked about earlier.
So sorry, in our case it's machine data.
Machine data, but some user is actually triggering the generation of the data. That is why I want to call it as user-generated data. Okay. But if you want to store how long, what is the hours of operation for the device, right? How long should it send the heartbeat information? That becomes config data. So that's the difference between config data and user data. And you deal with them separately because the config can change between tenants. User data changes with every user within the same tenant. That's how we look at it.
Right.
Yeah.
Because my follow-up question was, are there any compliance on this data as well? Like
compliance
GDPR
comes in user-generated data because you as a vendor do not even know what kind of data comes in. So tomorrow, imagine the same RFID data or IoT data actually sends some heart signals or some biometric signal. That is private information, right? So you should assume user-generated data will always have PII, but config data may not have PII. So in terms of storage, security consideration, you can actually have a lesser cost when it comes to config. Config data does not change frequently. Again, the kind of database that you choose can actually conform to a case where your config or your data movement, your queries are less, your data ingestion rate is less. So you can think about your storage very differently. That is why you need to classify the kind of data very well, because that determines the kind of infrastructure that you would use.
Correct. And just one more follow-up. So if you're building AI models on top of these data and you've got features that you're generating, how is that data looked upon?
So features is actually on user-generated content. Because config, I can recommend a configuration. You're not going to make money recommending what kind of configuration you should use on your software. That's a one-time config generation for your tenant, right? Though you can argue a use case on it, I'll not debate, right? Because, but it's a UGC, which is your mining data, which is your wealth or gold mine of information, right? So essentially, you will optimize UGCs for better storage, for better compliance, encryption, security, and better retrieval. That is why the classification was important. Good. Cool. I think we are on time. Thank you for the questions.